Hello there, this is David Spurway, the Power Systems Product Manager for the UK and Ireland, and I'd like to take you through 3 reasons why Amazon Web Services can be much more expensive than IBM Power Systems. The agenda I'm going to run through very quickly is the following. So how long are you going to be staying? This is a key question if you're going to be looking at the cloud. If you're going to be there for a while, then it actually makes a lot of sense to stay with IBM Power Systems. If you're going to be there for a very short period of time, maybe days or even just a couple of weeks, then capacity on demand, of course, can be a very effective option, but the cloud is also a very sensible choice at that point. But if you're going to be there for a while, then actually maybe buying your own might make still the very best financial sense. Advantage of good packing. When it comes to deciding whether you're going to be staying somewhere or not, there's always an advantage to good packing. You can do an awful lot with these different systems. You can fit an awful lot into a relatively small computational space. And if you're actually doing this yourself using the virtualization of Power Systems, this can be the most effective way to do it, and you can keep those advantages to yourself. Alternatively, you could let the cloud do it, but the cloud providers, this is one of the key ways they make their money, is by using this advantage of virtualization, the ability to pack lots of workloads into a relatively small computational space. That's how they make the majority of their cash, and if you do it yourself, then you can keep those savings to yourself, and they can be quite profound. Finally, you've got to watch out for the software. Software can be very expensive. It can really run up significant costs just in its own right. It's not at all uncommon to find that software is more expensive than hardware these days. And when it comes to comparing the Amazon Web Services deployment process, you can find that actually there's an element in there, which I'll take you through in a moment, that can potentially double all the Amazon Web Services costs, or to be more fair, double the cost of the software running within Amazon Web Services from the way that they actually provide their virtual CPUs. The software charges can be large to begin with, but once you double them, you're really looking at a very big bill indeed. So, let me show you what I'm talking about. We've got a lot of our customers have been considering a cloud-first strategy. Very common agenda to be on the CIO to CTO kind of priority list at this point would be a cloud-first strategy. And a lot of our customers, when we've been talking about potential deals we have going with our major customers, then Amazon Web Services is a very common competitor that comes up and is considered by our customers as a consideration for what they might want to do with their compute resources moving forward. It's being considered because they want to do a very rapid and simplistic speed of deployment, and of course Amazon Web Services does have a very easy way to roll out computational resources that doesn't require you to have the on-premise resources, and it can be a lot simpler. There are other choices in this space too, but it is a clear advantage of Amazon Web Services that they can be very simple. They also have a desire maybe to lower costs, and that of course is the key piece I want to query here. In the actual fact, rolling out into the cloud doesn't necessarily save you money at all. It can be a very expensive choice. We in IBM consider that hybrid cloud is the best way forward. That hybrid cloud can give her a good balance for the on-premise elements, plus also the flexibility in the new world of using cloud elements too. And one way of doing this, particularly on the on-premise side, is using the IBM Power Systems enterprise offerings. They can deliver excellent on-premise cloud capabilities, very flexible, very cost-effective. And when I say cost-effective, these are the kinds of numbers that I'm talking about. You can see on the left-hand side the very large bar of the Amazon Web Services costs. Little blue piece at the bottom, that's actually the hardware costs. Very large bar is the vast majority are the costs associated with the software. I'll take you through the details of how I get to that in a second. Intel, of course, is also a consideration, and I've got the ProLiant server there as an example that matches up to the same kind of performance as the computational resources used in Amazon Web Services, and you can see that it's a lot cheaper actually than doing it in Amazon Web Services, but also more expensive than actually running on the IBM Power Systems. And I'll take you through some of the details of how I get there in just a second. How do we lower costs after all? The key question here is about the costs, and let me take you through a little bit about how that works. This is what the initial total costs of acquisition might look like. So on the right hand side you've got one of our biggest, baddest boxes, an E880C, huge, great, powerful server, which does have a potentially very large sort of cost of ownership to begin with, a total cost of acquisition rather to begin with. I am looking here at a cost that is purely a list price, and it's a list price to buy the full server, and that's a lot more powerful than the little Amazon Web Services instance I've got on my left hand side, which is just an individual virtual machine from their M4 slate of offerings, which is a lot cheaper but also a lot smaller. But you can see that Amazon Web Service initially could be a very attractive option when it doesn't necessarily look like it's got a particularly big cost to it, but you need to layer things up a little bit to find out what the true total cost of ownership is, and that can take a little bit of digging to find out what the real details are behind the scenes. So let me look at my model about how this actually works. I don't need to go into a lot of detail here. I'll do more detail at another presentation that you can talk through that if you want to. But the key piece is fewer servers and fewer cores, that lowers the hardware costs. If you've got fewer cores per license, that lowers the software costs. So how do we do this? Well, we've got higher performance with the Power Systems than we do on the offerings from Amazon Web Services, which means you've got fewer cores and fewer servers. We can also do very effective, very high levels of utilization, particularly with the larger enterprise systems. That's the benefit, as I say, of how the cloud providers make their cash, is that they can potentially be keeping that benefit to themselves, and that's how they make their money. Alternatively, if you own your own servers and use the virtualization on those PCs, then you can get great benefit from those moving forward. So fewer servers means lower hardware costs, fewer cores means fewer licenses or PVUs, depending on how you charge for your software in the first place, and that lowers the software costs. So briefly, how can I claim higher performance? Well, that's because I can look at the performance of the individual servers. I look at the Amazon Web Services instance. I look at an Intel-based system, which is very much the same as the Amazon Web Services server behind the scenes. I can then look at a variety of different power boxes and the range of performances that I get from Gartner for these different types of boxes. And then I can divide the performance of the server through by the number of cores that I've actually got in the systems. And you can see that I've matched up the Intel box pretty closely, but the Power 8 systems are all more performant, have higher bars, therefore higher performance than any of the Intel systems that we're talking about here today. That covers the performance side, and then we get to the utilization, which, as I say, is a key factor in many of the TCO arguments that I work with, but particularly in this case. How do we look at this? Well, you could think of the golf balls in a jar kind of process. You can take yourself a big mayonnaise jar, fill it up with golf balls, and you look at it and say, well, that looks pretty full to me. But with packing, you can come along and maybe add in some pebbles. You can add in the small stones. They fit around the gaps of the larger golf balls. And for my analogy here, what I'm talking about is workloads. So you can fit smaller workloads or workloads that are simply not using as much resources at that particular moment in time around the busier workloads and fit them all together in the same kind of footprint. We can keep going with this and add in some sand around the sides, and you can keep going with that and pack your boxes a little bit more effectively. And finally, you can fit in some beer with friends, because there should always be time for beer with friends. And basically we can cram lots and lots and lots of things into our lives, or indeed, as I'm using the analogy here, into my virtual servers and physical servers, lots and lots of workloads crammed into the same kind of box. And that's the kind of thing we can do very effectively with the Power VM virtualization. And also you can do that yourself on premise with that virtualization, or alternatively you hand that benefit back to the cloud provider, and that's where he makes his money. This is the kind of effect that it has. So I've brought in the utilization kind of numbers here, and I do model this in a fairly detailed scientific way, which I'll cover in another session. Keep that utilization nice and high on these boxes. Also, of course, I'm considering the fact that I can use capacity on demand on my larger enterprise boxes, the big ones with the E in the beginning of the name. I can use capacity on demand on those systems to right size the servers to exactly what I need for the individual workloads that I'm working with. All my hardware here is at list price, which might not necessarily be how you actually consider buying it at the end of the day, but I do consider the point of view that with the cloud, you don't need to worry about the people costs for managing your individual servers. And I've got that covered in this model. That's why on the left-hand side there, the Amazon Web Services bar doesn't have any people costs on top. It's because I'm letting the cloud do that. But you can see actually that I have considerably cheaper versions available. For example, E850C or other options can be cheaper on the hardware side, even before I begin adding software, because of that benefit of high utilization, because of the benefit of packing the workloads effectively into a relatively small space. Then you got the kind of detailed technical point, which might be a bit more detailed than we really want to cover in lots of this particular discussion. But with Amazon Web Services, they have these virtual CPUs, and what you're actually getting there is a thread of an Intel Xeon core, not actually a physical core itself, that each one of the physical cores has two threads running against it. May seem a very techie detail, but it's very important when it comes to the software costs. In that Oracle and many others charge their software against the virtual CPUs, and that means that in this particular case, they're charging their software against the threads, not the physical cores. And when you're running your on-premise workloads, the software is charged against the physical cores. Here, if you're running it in Amazon Web Services, it's charged against the virtual CPUs instead, and that effectively doubles your software costs. And the software costs are big to begin with, but they effectively double those on the Amazon Web Services offering. So that's the kind of effect that it has, and that's why we have this great big software bar on the left-hand side option here on the Amazon Web Services. You can still see that the dark blue for the hardware, but the software is the really expensive piece that is now doubled up because of all the Oracle licenses you need, because of that combination of the lack of virtualization you're actually getting the benefit from there, and also that you charge on the thread, not the processor core. You can see then that software costs are significantly lower when I look across on the power boxes. This is because I can use that virtualization, lower the number of cores I need, and also charge the software on that particular core instead of the thread. The Oracle cost is also discounted. It's discounted at a 60% rate, which is relatively common that we see with many of our customers. The hardware is still at list price, but the software is the really important bar here, and so that's actually how Power Systems can be much, much cheaper than Amazon Web Services. A question you might be asking at this point is whether this is all about the relatively large scale that I'm operating at here. So let me also sort of get to that in a second, in that as we add in a couple of other layers of software, you can see that we're actually got more RAC Stack here. You get more software being added on. The more software I add, the larger the bill gets. So I'm looking at a sort of Oracle cost of about 27 million for Amazon Web Services against a hardware cost of 1.3. On the Power Systems side, I could have maybe a 2.9 million, which so nearly sort of, it's an order of magnitude cheaper on the software costs for the IBM Power Systems scenario, and the hardware is also cheaper, so £620,000 at list price as opposed to 1.3 million. So we're cheaper across the board, both on the hardware and also on the software side. As I say, this might be about scale, so let's have a little look at scale. And if I bring things down to a much smaller number of workloads, then Amazon Web Services still comes out as a very expensive option, even at a relatively small number of Oracle instances, and the Power Systems come out much cheaper at this point. I've kept in the LC box. It doesn't actually run Oracle on Power, but it's there just to be able to give a comparison. But the clear winner here is the E850C, and it's the one that actually comes out very effectively in this particular example. Look at maybe it's not just Oracle. Indeed, it's not just Oracle. If I look at IBM's software charging as well, we charge at the virtual CPU level as well, which means in Amazon Web Services you're charging by the thread. And that has the effect of making Web3 Application Server a very expensive piece of software to run in AWS as well. Lots and lots of PVUs need paid for there, lots and lots of cost. And again, we can come out very effectively using the IBM Power Systems and gain the benefit of that virtualization. You could consider using the LC boxes here because they actually come out very effective, lowering the hardware cost and also keeping the PVUs low. Then after you've got the cost balanced, you can look at other benefits. You can look at the availability and security kind of features and see what other options you want to look at. Amazon Web Services has had outages, so you can see what happens in that kind of space. Therefore, if you're controlling your own systems, you can control that with that availability and move forward from there. Security. AIX has had 6 security vulnerabilities reported this year, as reported by the IBM X-Force Exchange. I have to dial down from a year down to an individual month to be able to get the scale for Linux or Windows. 18 vulnerabilities reported for Linux in a single month and 30 for Windows. So that's 18 in Linux in a month versus 6 in a year for AIX. So far greater security, far fewer vulnerabilities on the AIX side of things, which is therefore a great place to run your Oracle workloads. So in summary, how long are you staying? If you're going to be there for just a little while, then you could consider using capacity on demand. If you're going to stay there for a while, if you're going to stay there for years, then it makes an awful lot of sense to just buy your own and then control the costs of that pump sittings. You can take advantage of good packing. You can fit less into a good space after all. You can control your software costs. If you let the cloud do it, they keep all the advantages. They keep the benefits of the high utilization, and you hand them over. Alternatively, if you own your own systems, you can control that. You can take the advantages of virtualization. And we know many customers who are running lots and lots of workloads in a relatively small number of processors and keep the advantages to themselves. Also, you've got to watch out for that software cost. So the software costs, after all, can be starting off pretty large. With the way that Amazon Web Services does its virtual CPUs, everything can be immediately doubled, and that's a very large cost you start with. It's promptly doubled, and therefore it can be far more cost effective to actually keep things to yourself and run them on-premise instead. So if you have any questions, feel free to track me down. You've got my contact details here. Give me an email or give me a phone, whatever you need to do, and I'll happily take your questions. Alternatively, the sort of summary, if you're all right with this, would be more data doesn't have to mean more hardware if you're using Power Systems. So consider Amazon Web Services. It's a perfectly reasonable option if you're there for a short term, but when it comes to being there for a long term, it can be a very cost-effective, very expensive option instead. Okay, thank you very much indeed for your time. Speak to you soon. Thanks, bye now.